mostly via Twitter. You can follow us over there, or all our meetup events are organized via Meetup. This is the shortened URL that you can follow along, or you can also join our Telegram channel, where we have all our active communications, and you can participate with our Hyderabad community, Python community. And we would also like to host you for our next events. And if you're ever interested to give any talk or like anything at all, any workshop, you can always submit your proposal over this URL. I'll read it out for you, or I'll share these links in the chat as well. You can always submit your proposals, and we are always welcome new speakers. With that, thank you. So moving on, we have our speaker for today is Pradyun. He is part of the core team for PIP. I'm sure mostly everyone is aware about PIP. And over to you, Pradyun. I would better let him give his own introduction. Sorry.
So many buttons. Okay. Hello, everyone. Just in case you just joined in and your video is choppy, you can follow these slides along on this link. It's a shortened link that does what it does. And you should be able to follow these slides. If you're not able to, there's a chat. Directly message me, let me know. And with that out of the way, let's get started. Whew. Okay. Hi, thanks for the introduction, Jatin, and thanks for inviting me to talk about this stuff. Good evening, everyone. I hope you're doing well, and everyone that you're around is also well in these rough times. And hopefully everyone's practicing social distancing and sitting at home where you're safe. So we're going for a, I hope, fun journey, exploring PIP's functionality and its internals, and talking about how PIP works. The link to these slides will be added after the talk when I am done with dinner at the link in the bottom corner, and you can follow me and blah, blah, blah on that link on basically every social media platform there is. Okay. Who am I? I'm Pradyun. I'm a member of Python Packaging Authority, a group of volunteers who maintain a lot of Python packaging infrastructure that keeps stuff running for a lot of people. I'm a maintainer of pip, virtualenv, packaging, and a few more Python-related stuff. And I'm a Python Software Foundation fellow. I'm also still a college student, although that's going to change in a few months. So we're going to talk about pip. And honestly, I need to make some assumptions about the audience. And given the fact that I can't see you right now, I'm going to just be very vocal about what those assumptions are. I'm expecting everyone here has a working knowledge of how Python works and a decent idea of what pip does. And that you know what the difference between the words distribution, module, package, and wheel is. If you don't know these differences, that's the link that you want to go to and take a look at. I'm not going to go too quickly, so you can take a look right now. These are the assumptions that I'm going to operate with. And with that out of the way, let's talk about the things we have to deal with. As pip is a package installer for Python, it has to fiddle around with a lot of stuff. And it helps to sort of have a common vocabulary, which, as I have referenced, we will be making some assumptions, but it doesn't hurt to reiterate. There's PyPI. This is the Python package index. It's where you mostly get your packages from, unless you're someone special. This is where you'll get your packages from in most cases. It's not what everyone uses, but this is in some ways the canonical source for pre-distributable software written in Python for reuse. This software is distributed in distributions. a distribution is really just a structured file containing additional information about its contents, metadata. And this is what we'd use to move the code around, to make it possible for it to go from the publisher's machine or the package developer's machine to those end users' machines. There's two forms of them, as those boxes probably hinted at. There's source distributions, which are really self-explanatory. They contain the source code. And then there's binary or built distributions, which essentially have everything that needs to happen to them already done. And the only thing that's needed to install them is to move the files that are in them to the right location. The most common example for this is wheels. So I'm just going to call them wheel distributions. There are others, but pip does not deal with those anymore. Not well anyway. So we're not going to go into that complexity. Wheels are special. So I'm going to spend a couple of moments talking about why wheels are special. They are built distributions. So everything about them is already known in some ways. So the file names actually have a very, very deterministic format that tells us a lot about the contents. This is sort of the metadata that I was talking about, additional information beyond just the files within it. So we know what version we have. We know what Python tags, what Python versions we're compatible with, what binary interfaces for those Python versions we're compatible with. So as you can see, in the case of Jinja 2, we're compatible with none, which basically means we have no requirements. So it's really, yeah, it's not compatible with, but more like require. Yeah, so that. And then there's a platform tag, which is which platforms am I compatible with? Any means everything. So it's a pure Python wheel. That's what Jinja 2 is. Whereas markup safe, well, it has dependencies on the platform or has compiled code possibly. So it only works on certain platforms with certain Python. And that is all represented within the wheels file net. So wheels are nice for that reason. But we'll get to more of that later. And then thirdly, we have environments, which contain, well, the install packages and whatever platform you're on, whether it's the Python version, whether it's the OS, architecture, those details, right? So all of those, I'm just going to encapsulate that with the word environment. And what pip basically does is some magic on top of these, and that makes stuff that's on PyPI get installed on your system. That magic is really just a carefully coordinated dance that looks something like this. It's carefully coordinated, but yes, it's really just a sequence of steps. And because at the end of the day, pip is a program, and it's just gonna follow a set procedure. My goal for today is to explain what's happening in this diagram, which represents a significant portion of pip's code base. And hopefully, by going through this, we'll all have a good idea of how a pip install works, right? So to take a simple example that, well, let's install Jinja 2, right? I'm assuming this is a blank environment that does not have anything already installed, but basically I ran this command on my machine. So I have a macOS machine, as you can probably tell now. So, well, okay, pip install Jinja 2. Pip goes and gets Jinja 2, downloads it, and then it gets markup safe, which Jinja 2 needs for running, and downloads it and then installs both of them. Great. Well, let's break this down a bit more. What exactly is pip doing in these steps? So, well, we're installing, so let's talk about that. We're doing a discovery step. We told pip install Jinja 2, but it went and downloaded a specific wheel file. How did it figure out which one to download? That's what I mean by discovery. Downloading, well, I mean, That's pretty self-explanatory. There's dependency resolution, which is basically figuring out, hey, what does Ginger 2 need to work properly? And figuring out a compatible set of these packages so that they work. It's actually a fairly difficult problem, but we'll get to that later. And building. Well, we're not doing any building here because we already have wheels, which are built distributions. And there's a sad smiley face here because building is a complicated topic, and I'm going to have to talk about that. So that's going to be fun. There's also the ability to introspect in pip as well as uninstallation. But as I hope the agenda showed, I'm not going to go into those because, well, they're not as interesting as the installation case. Okay, so we talked about what's happening in this output. Breaking it down, collecting roughly represents the discovery stage, downloading, well, downloading. There's no build happening here. And then there's the obvious installation and dependency resolution. And then obviously we're finally doing the installation because that's what we were here for. Okay, so discovery, what all can I get? What does this step entail? Well, quite a lot actually, because pip can install from a lot of places other than PyPI. Python package index, as I said, is just one of the possible package indexes. Many companies run a package index within their company's firewall or whatever you want to call it. And well, they do this for a bunch of reasons, but they do it. And well, they can. Then there's the option to directly install from URLs, which, I mean, I've done that a lot of times. It is really useful, as well as version control URLs, and from a local file or directory, because, well, you're not, how are people who are developing the software going to install the software they're developing? This way. You can also use a local wheelhouse, which is sort of basically, it's just a directory containing wheels, and then you point pip to it with a bunch of special flags, like mostly find links, and it just does what it's supposed to. The goal of the discovery step is really to get a bunch of URLs to distributions. There's criteria for what distributions we want to get the URLs of, though. They have to be from the sources that we're looking in, because you can't just look anywhere and everywhere. So we know what sources we're looking in, and they have to match certain requirements. They have to be what we want. Well, mostly this is the package name, the package version, the distribution format, so source distribution, wheel distributions, and platform compatibility. All of these are sort of requirements that we have. And if you look back at the file name of a wheel file, you can see all of these details are listed in them. So that's why wheels are nice. This step approximately represents this part. So discovery is what is giving us these, essentially, this part of our original graph that we were showing earlier on. We were looking at earlier on. Well, it's fairly self-evident what's happening. It's the starting step for our rest of the graph. The package index, and I'll dive a little deeper into that, is really just a bunch of links. All the information that we need about a package that we can get from a package index about the package is useful because it means we have to do less work later. So the package index essentially has a list of links to the distribution. There's a very simple format for this. That's a joke because simple is the name we gave the repository structure. That's why you see pypi.org/simple/6. So it's a very simple layout, which is a list of links. And those links can have additional data attributes that are well defined. So for example, you can see, even though 1.12.0 blah, blah, blah is not listed in the left side, it's lower down. You can see that there's a data requires Python, which represents what Python versions this works on. So 6 1.12.0 turns out it works on 2.6 and above, but not 3.0 and 3.1. That's what that represents. So it's a very simple layout. And yeah, if we break those URLs down, it's exactly what I said just now. So yay, I had a slide for it and I forgot. Okay, so downloading. This is fairly self-explanatory. And if you look carefully at the graph and it was not too blurred for you, well, there's a separate download step. There's edges that say download. And really, those are the ones that we care about when we're talking about downloading. It's fairly obvious what downloading means. It's given a URL, get it locally. And really, the devil is in the details. It's not really difficult to do downloads. Well, request exists. But what's difficult is sort of handling all of those nuances around it, such as having to do retries or authentication, and perhaps most importantly, caching, because not everyone has a really fast internet access. So, and also speed. Installation, well, pip install, you have to end up doing installations. That's really simple. There's a well-defined procedure for these. And that represents essentially the lower third of the graph that we started with, sorry. Yeah, as I said, there's a well-defined procedure for these things. When you have a wheel, because it's a built distribution, you just have to unpack it to the correct directory, and well, everything works. And if you have a source distribution, though, you need to do a lot more work. You will need to. You have two ways to do this. One is you can build a wheel and install using that because we know how to install from a wheel, or you can install directly from a source distribution. Pip tries really, really hard to only go with the first option, only option A, because option B depends on implementation details of setup tools in pip, which is not really nice, and we're trying to move away from those details. So really, pip tries really hard to go from option A. The other benefit of trying to do that is, well, you can cache the wheel that you build during this installation step. Yeah, not really. Yeah, yes. I don't know if I should call it an installation step if I'm also building in it, but bear with me. So yeah, once you have the build wheel, you can install that and cache that. And we are also caching the wheels that we downloaded. So if you're using wheels, you can use caching. And because there's all of the information about compatibility and all of that, it's really nice to use that. So wheels are easy. Source distributions, not so much, but we can make do with that. Whoop, where's my mouse? There it is. Okay, building. This is the part of pip that has a lot of complexity. Excuse me. The graph that we had, the middle of the graph, the part that was super messy, that is the part where, well, the build logic was represented. This part is really messy, jumping around. So let's talk about this in a little bit higher level. So there's two ways pip does builds. One is what I like to call legacy, which is directly calling setup.py. Yeah, like that. It just calls setup.py with a special syntax that setup.py has. That's really just a contract between pip and setup tools that neither party sort of communicated well around, whatever. And this contract, this calls represent the interaction needed to do the build. So there's getting the metadata, which is egg info. Why? Install, there's that. Develop is for editable installations. There's also something called bdist wheel, which I should have listed here, which builds a wheel distribution, but this is sort of not very great. But it works. And really, it's been the thing that worked for a really long time. And a lot of packages actually depend on this being the way that stuff works. Otherwise, they don't work. Nonetheless, there's another mechanism. And this is a lot more newer, so I like to say modern mechanism for builds. This is defined in PEP 5.7, 5.8, but it's just easier to say modern builds. So this essentially calls a build backend that by default is setup tools. So setup tools is no longer the special case where you can only use setup tools. You can use anything, it's just we default to setup tools. And this was a choice made for backwards compatibility because as I said, most packages expect you directly call setup tools. So yeah, setup.py info. Well, let setup tools do that call. We're just going to use it like a build backend. And by well, by having a well-defined mechanism that's defined in those proposals, PEPs, uh, we have the ability to use an alternative. That's why alternatives like poetry, like Flit, exist and work pretty well now. Uh, they could exist earlier, but then they had to do these weird shenanigans of mimicking what setup.py calls were. But now we have a cleaner way for them to do that. So let's look at this all over again. Do I have the ability to draw? I do not. Great. So, well, let's look at this more closely. So starting from the left, we have named local VCS and local unnamed VCS. These are, well, you can have version control system files cloned locally, and that's what this represents. And we basically go, okay, this is a modern project or a legacy project. And based on that, we determine how we're going to build a wheel. And if you were looking carefully earlier, we had the path for installing directly from a local legacy project. So legacy builds had the install, setup.py install. That is still possible. We try to avoid it, as I mentioned. The other way is if you get any other source, we will have to unpack those archives or source distributions and basically build a wheel. And if it's a modern project, it's going to build through 5 and 7s, the interface defined by that. And if it's legacy project, we're going to build a wheel through setup.py bdist wheel, which is, again, it works after all, but it is what it is. And that's it really. There's not much more to this diagram. There's the top half, which is getting the distributions after discovery, downloading them, doing a build step, and then installing them. There isn't much to it, and really the devil is in the details. There are a few quirks around the code base if you're actually going to try and work on pip's internals, which is pip actually does not do builds, it does prepares, which is really a weird mix of downloading, unpacking, and building a package, which is, well, just a quirk of how things were implemented. Uh, then there's the other problem. Pip uses requests, but you can't exactly pip install requests for making pip work. So the way pip works around this bootstrapping problem of needing dependencies while being the thing people use for doing dependency management, or at least installing those dependencies, the solution to that is, well, not depending on stuff and actually rendering it within. So we'll see this when we talk about the directory structure of pip. Pip actually has the source code of requests within it, so that it does not have to depend on an already installed request somewhere. It's distributed as part of pip. So that, well, it has a few benefits. The main one being you can't break pip by uninstalling requests or installing an incompatible version. And probably the biggest quirk is that it's an 11-year-old code base. And anybody who's worked on a code base that's that old will know there's a lot of technical debt, which basically refers to choices that were made that have consequences that you now have to deal with. This is usually said in the same way that debt financially works. You make a choice early on, and then, yeah, it's the same concept. Okay, so I'm hitting my time mark, so I'm happy about that. Directory structure. This is an unstructured discussion. So if you have questions, you can ask them in the question part. I see there's already one, Python 2 support. When are we dropping that? I will get to that at the end once we're done with this. But that's a good question that I will answer. Okay, so directory structure. Well, if you look at pip's source code, there's obviously documentation, tests, and source code. There's also two directories, tools and news. News is basically the directory containing things that we put into the release note eventually, release notes that you'll see on our documentation page. Tools is basically scripts for CI, scripts for various processes that are used as part of scripts and data and text files, basically, for development processes. Then there's the source directory, which has a main file, an init file, an internal directory, and a vendor directory. Let's start from the bottom. The vendor directory is what I talked about earlier. This is the directory that will contain a folder named requests, which has all of the files for requests. And we have a process for doing all of this that we use so that, you can't install the requests and break pip because guess what? Pip's using its own requests. The other is an internal directory. This was done quite a while back in 2018 or something. So not too long ago, but fairly long ago, where we basically moved all of the code that is pip into a separate directory with an underscore to tell people to stop using them, because pip is a command line tool, not a Python package or a Python library. And people were using the implementation details of the command line tool because they could import pip. So this change was done with the motivation to tell people more directly that, hey, do not depend on this because these are internal details. And then the underscore main or dunder main file is what Python uses to let you do Python minus m pip. So if you type that on the command line, you can actually use pip. So you don't even need pip's executable to be available on the path. As long as you have Python and it has pip installed, you can use Python minus m pip. And then in it, it's fairly obvious what it's for. I did say working knowledge of Python. Okay, now let's dive into the internals folder. So it's fairly well organized now. There's been a lot of technical debt paid down over the years. So most of this is fairly obvious. CLI, command line interface, that defines all of the utilities, all the command line parsing and all of that logic. That contains that logic, rather. Commands contains all the logic that is specific to each command. So you'll see files for every command within this folder. So every pip whatever command that you can write on the CLI, that essentially originates from a folder, from this folder. And specifically, it'll be a file in this folder. Index is all the logic for interacting with package indexes. Distributions is logic for interacting with distributions. So this is, well, not super clean yet, but this is where we'd eventually put the logic for doing builds, doing installations. And this essentially creates objects, contains the object representations of those files at the end. Yes, of those files that we'll use as distributions. I think I tied myself into a knot there, but it's should be fairly clear what I meant, I hope. Models, anyone who's done databases knows these are essentially, pip does not have a database, but we have a similar structure to basically representing things with these models and while we're using them in memory. So that essentially lets us represent things more cleanly. And we have a clear definition of all of these. These represent things that jump around through the code base. So it's good to have a single place to get the definition for those from. Network, fairly obvious. Networking, all the download logic, everything is within this. Operations represents the potential operations that we could do on a distribution. This really needs to move into the distributions folder, but it is where it is right now. I'm going to skip rec and come back to it at the end of the slide. Resolution is where all of the dependency resolution logic now finally resides. This is the logic for seeing a dependency going, seeing a package going, okay, what do you depend on? Oh, you depend on these. Okay, I'll get those. And then doing the same step for each of those until you have a compatible set of packages. And if anyone here is familiar with dependency resolution, they'd know that this is an NP-hard problem. So this is about as complicated as it gets algorithmically. Then there's utils, which is just general utilities that are used, file system handling, little things that don't really deserve to be functions on their own within the same file, but can be reused and things like that. And then VCS, this represents version control system. So all the logic for a version control system, all the interaction that pip has with a version control system, those are actually defined here, and all the logic for that is contained within this folder. Okay, rec. Remember I mentioned technical debt? Well, over time, we have managed to consolidate all of our technical debt into this one folder. So rec essentially is short for requirements, and pip internally represents any user input as an install requirement. So if you say pip install Ginger2, pip will create a install requirement object with the name Ginger2 and do operations on that. We're slowly changing that. This is definitely the most difficult part of the code base to reason about. But this is also the part where, well, all of the build logic coordination, all of the directory management during build is happening. So it is a part of pip that we can't skip, to be honest. Okay, there is more text here. Okay, no more questions yet? Okay, I'm good. Feel free to drop questions. If you're not sure how to drop questions, there should be a thing in the side that says questions. Yeah, okay, so folders and files. Files within the internal folder. Okay, sorry, I tied myself into a knot there. Okay, so there's a build environment .py, which, well, fairly obvious. It determines how to handle build environments and blah, blah, blah for modern builds. Legacy builds have a no-op build environment. Basically, the build environment, there's no build environment for legacy builds. They're just built in whatever environment pip install has been running. Modern builds actually isolate theirs from the environment, which has its quirks, but it works fairly well. There's a cache defining all the caches that we use. There's the ability to configure pip. You can use pip-config, or you can have a pip.ini file somewhere in the appropriate location in the file system that is documented. There's exceptions for multiple files being reused, reusing that. Locations, this is where we define all the magic location logic. All of the logic for getting to know from Python, hey, where do I install this stuff? Hey, what is this supposed, where do I put scripts? Where do I put installation files? Where is your site packages? All those details are essentially encapsulated in this. Main.py is one of the places where we have the definition of the main function in some ways. Self-out check, outdated check. This is what prints the prompt, hey, upgrade your pip because you're on an old version. This is where the logic for that is. PyProject.py, this is the file containing the logic for determining whether we're going to do legacy builds or we're going to do modern builds. The logic for choosing that is based on essentially the presence of a pyproject.toml file, which is why this full file is named the way it is. And yeah, that's what this file does. And it contains all the helpers for reading a toml file and all of that stuff. Wheel Builder is the file containing a lot of the logic for coordinating wheel builds from install requirements, which is why it's not in an operations or a distributions directory, because it's handling a lot of the install requirement and build logic interactions, the technical debt, higher technical debt stuff. So we haven't actually cleaned that up yet. And yeah, that's it for the internal folder. There's commands, and in case you didn't know what commands pip had, here is a list of them. No, but more seriously, all of these commands do different things. So pip actually has a lot of functionality within it. We haven't actually gone into all of these, but mostly the one that we were concerned with was install.py, specifically around how the flow of it is in some senses, of a single package installation that you try, how it goes from not being on the system to being installed on the system. But there's a whole bunch more of logic here, which is actually calling the dependency resolver, because that was not represented in our graph, and things like that. There's also a bunch of introspection stuff. So you can do list, show, freeze. You can get the hashes for certain files. And there are additional ways to get stuff. So there's pip download and pip wheel. And then finally, there's the ability to uninstall things once you have them installed. So yeah, there's all that. Hopefully by now, it's clear what's happening in this diagram. We skipped over the dependency resolution stuff within this diagram, but hopefully it's fairly clear what this diagram represents. It represents how you go from a file that's not on the system, or on the system, in which case it's a local something, and to go from that to something that's installed on the system. You can have editable installations, which, again, working knowledge of Python is assumed, so which you can modify while it's already installed, because it's in some ways a symbolic link, sometimes actually a symbolic link, depending on which tool you're using for the develop installation. Set of tools uses an egg link, because quirks and strong, strong coupling between those two. And yeah, so that's about it. So let's get into the questions. Python 2 support is still on. When are we dropping that? Now, I'm being careful when I'm answering this, because I see the attendees and I see some people who would be very, very careful, who make me think I should be very careful about how I answer this. So Python 2 support in pip still exists, because pip is a way for people to get packages to essentially avoid being stung too hard by the fact that they're still on Python 2. So as an example of this, backports for a lot of new enhancements in the Python standard library, they're available through PyPI, and people use pip to install stuff. And the other is, there was a strong sense of disconnect in the usage that we were seeing, and the fact that Python 2 was EOL'd, which is, even though Python 2 was end of life, a significant portion, like 40% or more, downloads from PyPI were happening from Python 2 systems. So either we had two options, either sort of go, okay, we're going to drop support for 40% of people who are using PyPI and Python in some ways, or we could keep it around for a bit and then drop that support. And we ended up deciding second, which is keep the support for a bit until the usage dies a lot, so that we don't have, we can let most people sort of jump the Python 3 bus even though they're late. So yes, when are we dropping that? Whenever the usage is fairly low, and honestly, whenever a whole bunch of pip maintainers go, yeah, that's fine. We can leave like those 10% people or those 5% users. I don't know the number yet. I still have to go look at the PyPI download data this month to figure out if we want to drop support this next release or whatnot. But yeah, we're not sure yet. The idea is when the usage gets significantly low, we will drop the support. But what significantly low means, we're still figuring that out. Pip install triggers discovery, download, dependency resolution. Or does it occur at the time of downloading pip? And the last step of install is run at this step. Okay, so I'm not 100% sure what the question is, but I guess clarifying what the order of installation, the stages of an install are, would help. So let me try and do that. So when you do a pip install, the first step that pip does is looks at all the packages that you've specified and goes, okay, so these are the requirements that I have. Let me go try to figure out how I can satisfy them. So it does a discovery step on these packages. And once it has done this discovery step, it basically knows, okay, I have these links that I can download 6 from, or these links is where I can download Jinja2 from, right? And then it goes and does that download from whichever link it thinks is best, which is usually just the highest compatible wheel. So it tries to download a wheel file that is the highest version and compatible with the system. If it can't find a wheel file that's compatible with the version with the system, it finds the source distribution with the highest compatible version on that version. So it prefers the version, and then it prefers the wheel. So you will get the latest wheel, and if that's not there, then you'll get the latest source distribution. If neither of them are there, you'll get, well, something else entirely. You'll get an older version, sorry. Once it does this download, it goes, okay, so Ginger, I have you downloaded. Tell me what you need to work. What are your dependencies? This then gives us a bunch of requirements, and that triggers the loop again, which is now go do a discovery on this requirement that we got, and then do a download, and then do dependency resolution on that. And then just keep doing this until you have a compatible set. There's quirks here. I don't want to go into the details of dependency resolution, but essentially, once you do this looping logic for discovery, download, explore, discovery, download, explore, once you do that, and you have a compatible set, pip just goes, okay, here, I have a set of requirements to install. Let me just install these set of requirements. And then it installs them, basically. Ooh, I'm falling behind on questions. Can I say what a wheel contains? I see in the grocery, well, a wheel does contain compiled files. Depending, I mean, if there are compiled files to begin with. Essentially, what a wheel is a zip file that is unpacked directly into your site packages directory. which is where Python imports stuff from. So a wheel file represents everything that has been done on this package to give us something that can be installed directly. So if there were C extensions, those are compiled and included as part of the wheel file. So yes, there are compiled files. I am not sure if the glossary says not compiled files, but if that is the case, we should uh, fix that in the glossary. Uh, so that might be a documentation fix that's needed. Can we consume PyPI packages using pip? Yes, that is what pip does by default. Uh, when I use pip, it will first install package to call system libraries to install the same package. It can also check and patch up if needed. I am not sure what you're asking, to be honest, because pip does not directly call system libraries. Uh, can you explain your GSOC project and share your GSOC proposal for reference? Okay, so I was a Google Server of Code 2017 student, and well, I don't know if I have a good way to show links right now, but yeah, I don't have a good way to show links right now. But yeah, my proposal is public. You search for my name, Pradyun Gedam, GSOC 2017. I think you get a link to my GSOC proposal. So, okay, what was my GSOC proposal? My GSOC proposal was actually to project, rather, was actually to improve dependency resolution in pip, because that is, well, the way pip does dependency resolution is very optimistic and doesn't really work. It does not get a compatible set of packages all the time. Why do I get pip not recognized as internal or external command? Well, that's because pip is not visible to your command line. So you want to basically figure out what's wrong with the setup that you have and identify why you do not have the pip executable on path. There are guides and there's lots of documentation and information about this that you can look it up. How is pip different from CI tools like Jenkins? Well, they're different domains, really. Pip is a package manager for Python packages. So something along closer to, uh, let's see, npm or apt or brew. It's closer to that. It's not really related to Jenkins beyond the fact that you can use it within Jenkins to manage your Python packages. And can we get a list of all sources that pip uses? Well, by default, the only source that pip uses is the Python package index. So if you just say pip install Jinja2, it will just go check on PyPI what versions of Jinja2 are uploaded there. The other sources are actually pip is configured to look at them at runtime by the user. So you basically say pip, don't look on PyPI, go look somewhere else. So you can pass a --index -URL file to tell pip, go look on a different index and things like that. There is documentation on all of this in pip's user guide. So that is probably where you can go look at that. Ooh, more questions, more questions. Let's see. How to start contributing to pip. There is, how do you start contributing to pip? Well, there is a getting started guide in pip's development documentation to help you with this. Basically, get set up on your development environment, and just like any other open source project, find a way to find an issue to contribute on, and or reach out to us on any of the communication channels mentioned in our documentation, and we can help you get started. Can we build pip like a GitLab pipeline? I am not sure what the question is here, to be honest. Like, you can use pip in a GitLab pipeline, but I mean, What does build pip like mean? I don't know. I'm not sure what your question is. So feel free to clarify that and then follow up. Where does the name pip come from? I am not sure because I have only been involved since 2017 and pip is a lot older than that. Uh, that is a good question to ask everyone else. I will get back to you on that, Devesh. Uh, any suggestions slash techniques, tools to create PyPI packages that can be compatibly installed using pip? Yes, there is. Uh, the canonical source of documentation for the current best practices in Python packaging is packaging.python.org. There are guides and discussions and reference material on that URL. I will say it again, packaging.python.org. That is where you will get a lot of the information about how to, you know, create a PyPI package that can be installed using pip, uh, manage dependencies in an environment, and things like that. What's the difference between building a wheel using bdist wheel uh, during creating a package and building wheels while installing a package? Well, wheel builds, okay, legacy wheel builds. Uh, how do I phrase this question in an easier way? Okay, when you're building a wheel for installation, uh, that is done in the same way as building a wheel when you're creating a package. Those are really the same step. Those are really the same things happening. So when you're building a wheel locally with a PDIS wheel directly on setup to on the command line, that is the same as doing pip install something and pip building a wheel uh, if it's going via the legacy mechanism. And so there's no difference when you're building a wheel directly or using pip to build it. The area that might be confusing is there's a loop in dependency resolution, and within that loop, we occasionally build wheels. So dependency resolution and the looping logic is what makes a lot of this stuff quirky, and also where a lot of the technical debt originated from. How does pip know what packages are installed in an environment? That is an excellent question. So there is a very standard format. There is a standard way to represent what is installed on a Python set in a Python environment. There's basically .distinfo directories. So if you go look into your site packages directory, you will see all the packages, and then you'll also see a whole bunch of something .distinfo packages. Those are metadata databases. So pip essentially uses the file system itself as a database to store the data that we want, which is all the information about this stuff is installed on the system or in this Python environment. And when you do pip list, for example, what pip is essentially doing is going and looking, what distinfo folders do we have here? Okay, what is within those folders? Okay, sure, this is the information about what's installed on your system. So that's in your environment. So that's how pip knows what packages are installed. Excellent question that I skipped during the talk because I was going too deep in that. Speaking of npm, is it possible to configure pip to install modules similar to node modules? Not yet, but there is an enhancement proposal to make it possible for Python to find these things because it's easy enough for pip to dump those files there. But what is really tricky is getting Python to go and look in that folder when you say import Jinja to actually go to that folder and do the import. So the issue here is not whether you can make pip put stuff there, which is possible right now, but more along the lines of making Python itself look there. There are proposals for doing this. I think PEP 582, which I remember PEP names. That's the sort of person I am. PP582 essentially contains the information about, contains a proposal to improve Python to have a PyPackages directory similar to node modules, except flat. So you don't have a nested nature like node modules has, which is you can end up with 20 copies of the same package because a package depends on it. 20 packages depend on it. Instead of that, it'll still be a single environment essentially, but local to the project, local to the directory. And within that dunder PyPackages directory in the root of your project. Similar to node modules, but different because the import systems and the management within those packages ecosystems works differently. What new changes will come with the new dependencies? This is included in the announcement that we made about this, but essentially it'll be stricter and it'll essentially give you compatible set of packages more often and refuse to install incompatible sets of packages. What is the advantage of having source distributions over built distributions? Why are there two formats? There are two formats for legacy reasons, uh, and also because it is really useful to have source code when, say, you're very pedantic and you want to compile everything because you're Debian or somebody who wants to ensure binary compatibility on your within your system for some reason. Like there are a lot of reasons to have access to source code, and uh, that is basically why. Some of those reasons would just be the fact that you don't want code compiled by other people within your system because you have reasons to do so. And these reasons are anything from having strict control over the binaries that are being used within, say, your company or your ecosystem if you're a distribution. And yeah, that's sort of how that works. Uh, can I expand a bit on serve.py as well? Well, there's not much to do on pip's end, and we're almost over time. So I'll just quickly say a sentence about this, which is it from pip's side, all it does is calls a subprocess and it gets a file at the end. On setup tools side, what it's doing is basically taking, okay, this is a folder. I will put these files of this folder into a archive, and then that's the archive I will put in a different location, specific location, and that's it. And pip just knows where it will put the archive. So it calls the subprocess, and setup tools does this, puts everything in one place and puts that archive into a specific place, and then pip's going to use that. Okay, I successfully managed to keep up with the questions, so yay. And that's about it. So that's it from me. Over to you, Chetan.
Sure. Thank you so much, Pradyun, for sharing so much details and answering so many great questions. And thank you, everyone, for attending. Before we go any further, first, I would like to thank EPAM for helping us organize this event by sharing the GoToWebinar details. Secondly, Pradyun, I would also like to ask you that if you can share some personal like connection platforms over the chat so that others can reach out to you for any further questions. Now, with that said, we wanted to do something over here. What we wanted to do was we wanted to keep a small job opening session. So we invite all the attendees, whoever has, if they have any openings in their organizations, and they want they are looking for some new resources to join. Can you please put up your job openings in the questions or in the chat box, and we'll call it out for everyone. Basically, if you're willing to refer anyone in your organization, I'll give you, we'll give you 2 to 3 minutes. If you have any openings, you can add it to the questions or the chat. By the way, Pradyun has already shared his social media handle. That's Pradyun SG. I'll spell it out for you. PRADYUNSG on all platforms, Twitter, GitHub.
Alrighty. Thanks, everyone. I'm gonna leave and go have dinner now. Have a good evening.
Uh,
Good night,
Thank you so
everyone.
much,
Bye.
Pradyun. Thank you so much, Pradyun, for sharing such a wonderful session.
Thanks, Jatin, and thanks for inviting me as well. Bye bye.
Bye. So we'll have a couple of more minutes if anyone wants to share any job openings. Okay, I think since we don't have any, I don't see anything so far. All right, we'll call it a day. Thank you so much, everyone, for joining, and thanks, special thanks to EPAM for helping us organize this event. Thank you, everyone. Stay safe. Take care. Bye.